So what we wanted to do first, though, is I know we don't have a huge number of folks on, so we thought it would be nice to go and just kind of do some introductions real quick of who all's on the phone. So I can start. My name's Angie Stalker. I am part of the Google Cloud team that supports organizations here in Cincinnati. How about Joyce, you go last and she'll be presenting so you can wrap us up. And so Andy, can I pass it off to you?
Yep, of course. My name is Andy Lawrence. I'm a customer engineer at Google, known to the rest of the world as a sales engineer type role. Got a lot of background in cloud and software development, a lot of things. And hopefully I can add a couple of color commentation segments here this morning.
And then if we can get our attendees, you guys want to just do a quick introduction?
Yeah, hi. This is Samir here. Yeah, I've been in the IT world for like past 2 decades, and I'm kind of a prospective startup, trying to establish a startup.
Great. Welcome.
This is Tyrone Gore. I'm the founder of SlamMail. It's also a startup and just trying to get familiar with Google Cloud.
Great.
Anybody else? Angie, I'll go ahead and mention that, and Joyce, I assume it's okay with you. As you're talking through this morning, if you have questions, feel free to go ahead and type them into the chat window or the Q&A window, either way. And we'll try to get them either answered at the end, or if we can intersperse them in the middle, we'll do just that. But go ahead and type them in the chat and see what we can do.
All right, so Joyce, you want to introduce yourself and then kick us off?
Yes, perfect. Good morning, everyone. My name is Joyce Muller. I'm a Google Cloud customer engineer, same role as Andy. I reside in Cincinnati, Ohio, and I work with our customers here. I'm a generalist, so I've worked on everything from marketing analytics databases to e-commerce platforms to data science workbenches, things like that. And today, we're going to talk about building for scale on a budget. Scale in this case means large or small, and especially in the case of startups, it means the ability to start small and grow from there. Overall, at Google Cloud, what we most want to do is make sure that you're getting value for what you're consuming and you're only paying for what you're consuming, and we're identifying where you're idle and avoiding charging for costs for those types of resources. So there'll be two parts to this presentation. The first part is more technical in nature, talking about the architecture patterns for compute and data and how they impact cost and how you can use mechanisms that are part of those services in order to reduce your costs. And then the second part of the presentation will be about more of an administrative look at billing and reporting and why it's important to get started early with exporting your bills so that you can understand things like how much does my app cost, how much are these particular people charging, what exactly are the cost drivers and things of that nature. So first half is more architectural patterns and second half is more administrative billing and deep dives into those sorts of topics. The entire presentation won't be more than about 30 minutes, I would say. And again, as Andy had mentioned, please feel free to put questions in the chat and we'll answer them as we go, and or as it makes sense, we'll answer them at the end as well. Let's see if I can get myself here. There we go. So to get started, let's talk about scale at Google. There are 9 products that Google offers with over 1 billion users each. In all of the world, there are only about a dozen products on the planet with 1 billion users each. For Google, it's things like Google Search and Android and Maps and Play and things you use every day like YouTube and Chrome, Drive, Mail, and Photos. Just wondering, we have a few participants, but if you want to guess, what are some of the other user apps out there that have over 1 billion users each? Anyone want to take a guess? You can just type into the chat if you have a thought. If not, I'll give you the answers.
You don't want
Fairly
me to say
obvious
it.
one. Andy, are you guessing?
No, I was going to sing the Jeopardy music for you, but I decided against it.
But no. I think everyone's still a little bit sleepy, so I'll go ahead and give the answer, which is that Facebook owns some of these scalable apps, one being Facebook itself, Instagram, WhatsApp, notably none from Amazon or Microsoft, but one that I was thinking about that might have 1 billion users, given that we're all in quarantine right now. This is the time of COVID-19, since it's being recorded. A lot of us have children at home, and they are all doing TikTok day and night. There are only 800 million TikTok users right now, so that's not quite 1 billion. And then I thought about Netflix, because everyone's watching Netflix. There are only about 170 million subscribers, although I heard last week that rose by about 15 million more. And if you consider household use, it's approaching 1 billion users, perhaps. But what does this mean for Google? It means that in order to deliver those products to 1 billion end users, we have over 30,000 developers, 9 million source files, 2 billion lines of code, and so it's quite a scaled operation. What does this mean for you? I don't think you're quite that large just yet. But large or small, no matter your size, budget is all relative. We have to stay in budget, you have to stay in budget. And so it's important that when you choose a cloud provider, they have those mechanisms built into the platform to help you make sure that both, again, from an architecture pattern perspective, as well as from a administrative analysis perspective, you can stay within budget. And so given the scale that we have, we certainly know a bit about managing that data granularly. So, and like everyone, we started small. This is the original bill for data center space, the very first month, I believe, that Google was in existence. You can see on the bottom right there, the customer's initial is Larry Page, LP, where our budget was on the mode that yours is probably on now, in the thousands of dollars per month for data center space. And what we might have looked back then as, and you probably look like now, is maybe you have 5 developers, maybe you have tens of thousands of lines of code, and maybe 1,000 source files. So I'm here to address what it is to scale on that budget and to make architectures that are resilient, that the Google Cloud supports multi-region failover no matter your size, right? So we do have customers like Snap and Target and Disney that take advantage of that. But scaling is not just up, it's also down. So we want to make sure that our smallest customers are spending money wisely on compute and data that's needed, and not spending money on idle machines. So as far as the agenda, first 2 parts, again, we'll cover compute and data. I wouldn't consider this to be incredibly technical conversation. We're just going to kind of give you an overview of the different types of services that we offer and how you can control costs in them. And then numbers 3 and 4 there is more the administrative view of examples of billing dashboards and exports and budgeting and setting budget alerts. And then at the end, I'll have a number of resources that you can go and watch either on YouTube or white papers to learn more. Starting with compute. Your app can scale in each of these computing models, whether it's virtual machines or containers or serverless. We can meet you wherever you're at today. Generally speaking, as you move from left to right here, from VMs to containers to serverless, you'll find that there are advantages in the ability to scale more granularly, and there are advantages in the ways to control costs and pay only for what you're using. Your ability to choose from these 3 often depends upon the way your application is written, perhaps some legacy dependencies you might have, and the skill sets of your organization. But it is definitely a path that you can get on, even if you're starting virtual machines. You can get into Google Cloud and grow from there and evolve your application towards containers and towards serverless. If you're thinking of using virtual machines on Google Cloud, that would be Google Compute Engine, GC instances. For containers, well, it's great that you can break up your application into these smaller services or microservices. Scaling is kind of easy when it's a few containers, but gets more complicated and you need an orchestrator as you grow, and that is Google Kubernetes Engine, known as GKE. And then finally, serverless. We have a number of different offerings in this area, some of them more sophisticated than others, but it's basically a cloud native model where you just develop code, put it in a container, toss it over to our service, and it runs it. So there's Cloud Functions, there's App Engine, but also there's Cloud Run, which Cloud Run is the most sophisticated of the three and the true serverless option. And I'll go into more detail on each of these types of models of compute and how we manage them and how you would set up an architecture pattern. So starting with VM-based scaling, you know, a lot of people are still in this mode because it's a place where there's significant skill sets, right, available. And it has a proven track record. And originally, you know, back at the beginning of the 2000s, VM-based scaling was extremely beneficial to organizations because it allowed them to put multiple applications on a single server. I know that's totally a given today, but back at the time, this was a big cost savings vehicle for a lot of organizations who went through this whole P2V, physical to virtual transition. And many people are still in that mode, and that's great. And so when utilizing VMs in Google Cloud, the pattern would look something like this, and that you would have a load balancing engine out front that would answer the calls from clients, and it would do the work of making sure that it distributed the load across to multiple VMs on your back end, which has significant benefits to you with regards to the reliability of your application, as well as the scalability of your application. And then just as a for example, those virtual machines may call out to a Cloud SQL database or other data backend when it needs to do a transaction or store data or whatever it may be. But that's the general model. And one other important thing to point out is that our virtual machines can be put into what's called a managed instance group. That managed instance group handles a lot of things for you around scaling, around making sure that those, not only is that load balancer sending requests to a number of different VMs, but it's sending them to VMs that are evenly distributed across our zones, our availability zones, or even our regions. So this is the basic pattern. Now, use of VMs, when you lift and shift them from on-prem into Google Cloud or any cloud, had gotten something of a bad name in some ways because it could be very costly. People that operate in the cloud, same as they did in their data center, are not necessarily taking advantage of the ability to scale up and down on demand as they should, right? So in 2018, RightScale did a survey, and many people said that I think it's up to 35% of cloud spending is waste. And a lot of this is because their VMs that they lifted and shifted in the cloud were over provisioned, or they're running constantly or all the time. And so cloud providers, ourselves included, worked hard to make sure that we could make this a more cost-effective way to operate, and today it absolutely is. So a few of the things that help you reduce costs when using virtual machines would include the fact that, of course, they are paid per use, right? There is no startup cost, there is no fee for termination. And if you have a bunch of developers using their own VM or whatever for development, it makes sense to shut those VMs down in the off hours. If you were to shut them down every night, for example, you could save 2 to 3 days of billing costs each week. Now, obviously, if it's a production web app, you're not going to shut it down at night, but for developer instances and things like that, it would make sense to make sure that you're automating that quiescing of your systems at night and then maybe turning them back up during the day. Another thing that GCP offers, Google Cloud Platform offers, is custom machine types. By using custom machine types, you can get very specific about the number of CPUs you want and the amount of RAM you want, and make sure it suits exactly what you need, so that you're not paying for any more or any size. Maybe maybe you have a very compute-intensive application, doesn't need much memory. You can balance that out, or the opposite. You have a low compute intensity but need for high memory. You can make a machine that matches exactly your workload. Another great thing that Google Cloud does automatically that requires no action on your part is that we provide you with sustained use discounts. So if you were to start at the beginning of the month and you're using 4 vCPUs, and you use them throughout the entire month, you would get a certain discount, right? So anything above use of them 25% across the month provides you a discount. If in the middle of the month you added another 12 these CPUs, those would also get a discount because they ran for 50% of the month. And we just introduced yesterday, generally availability, the ability to tell you when you have idle VMs, right? So we actually track and we'll tell you if you've not had any significant amount of CPU usage or consumption over the course of 14 days, we will actually alert you here in the recommendations category and tell you that you may want to actually turn off this VM entirely, that you shouldn't be spending money on it, you're not using it. And for a long time, we've also had the ability to tell you that perhaps you have an oversized VM. So it would tell you that, hey, you're using an N1 standard 8, and we really think this would fit into a micro, and that would save you X dollars per month. And those recommendations are right there in the dashboard for you to take a look at. So moving on from compute engine to container-based scaling. So GKE can be very effective at helping you manage costs and resources because the use of compute in this architecture model is a bit more granular, right? Through the use of autoscalers that are part of GKE, the most load-intensive portion of your application will scale up while the rest of it stays right-sized. So if I were to give you an example, it would be that for a retailer, retail e-commerce type application, they would have many components. I mean, as much as 100 on that first web page that you hit, that might be services such as adding something to your cart, or searching for a particular product, or checking out, or a promotion banner that comes up. So all of these are independent services. Each of them probably run as a microservice in a container. And depending on how busy it is, if, for example, lots of people are doing transactions, that point of sale portion of microservice would scale up, while the promotions service could stay on a much smaller number of nodes and pods. So in that way, you start to get very granular control over at the application level, making sure that you're only scaling the portions that are needed. The pattern for this looks extremely similar to the VM one that I just showed. It's a little bit different though, in that still there's this load balancing engine out front that's going to send traffic to an ingress on GKE and Kubernetes cluster. And then from there, the fundamental difference is what kind of I just pointed out, that the application itself is no longer a monolith. It's more of a modern approach. There's this flexibility to scale individual nodes and pods and services independently. So over the course of time, the capacity that they consume will vary and will match exactly what the demand is for your application, rather than you having to guess how many VMs you need to put up. Kubernetes engine will actually let you know, will for you auto scale the number of nodes and pods and things that it needs. So that's kind of the difference between that and a VM-based environment. Determining when you make this transition to containers really depends a lot on application architecture, the ability of developers to turn these into containerized service. And it's something that can be done over time. You can start as VMs. We even have some ability to convert VMs in place into containers if that's what makes sense for you. But generally speaking, you'll want to kind of re-platform and refactor your application to take advantage of containers.
I just want to throw in real quick that both the VM version of this and the container version of this allow you to scale up and down, including down all the way to 0 if need be. So when we talk about cost and cost management, you can certainly set that up so that if you're really not using it, not only will you get notifications like Joyce was talking about a minute ago that, hey, maybe you should turn this off, but you can configure it in a way that things are just shut down until there's demand for it again, and then they'll be spun back up. So.
Yep, absolutely. Great segue into the managing the cost with containers, which is, again, the same as VMs, that there's no upfront cost. And if you want to terminate everything, you can go ahead and there's no fee for that. There's a few ways within GKE to scale, as Andy said, all the up and all the way down to 0. One is at the cluster level, which is the number of nodes that you have that are serving your application. You could also scale horizontally within the managing which containers run on which particular nodes, and it tries to really optimize the fit You can even like do taints where you make sure that, say you have something that's super compute intensive, it moves to that high CPU node, and no one else can use that node. Or if you have GPUs in there and you want to conserve who's able to use them, you can assign that as well. And then you can also just use larger or smaller machines within your particular node pools. So beyond VMs and containers, we move on to serverless. Someone once said to me that serverless and containers are like peanut butter and jelly. They make each other better. I really don't know what that means, to be honest, but I just like peanut butter and jelly, and it looked like a great little image to add to this. So your ability to take advantage of serverless is something I'll explain here in a minute, but essentially it's code and go. So your developers could be fully just focused on writing their applications, and they simply deploy them. There are no nodes, pods, IP spaces. There's no startup time. The architecture is incredibly simple, which I'll show you in a minute, and it will make you incredibly productive, right? So the biggest cost savings here is really around productivity and the time your developers and labor and things like that. Now, just take a look at the pattern here real quick. It's just Cloud Run. So Cloud Run manages everything as far as scale, as far as balancing, as far as what node should run what. And it's called serverless. It's not that there aren't servers there. There are servers there, but you don't have to manage them. You don't have to pick the number of nodes. You don't have to pick the number of servers, the size of them. You don't have to think about any of that. We are simply giving you a platform on which to run your code. It has to be containerized. It also has to be stateless, and it also has to answer to HTTP 1.1. So there's some things that keep all applications being able to move to serverless today, but it's definitely an aim and a goal to head towards, because there are significant advantages in operational costs and productivity, and paying for the exact usage and just overall simplicity. Because the biggest benefit that you are bringing to your new company that you are starting is your innovation, your ability to code, your ability to deliver function to the user, and that's everything that you focus on with serverless, right? With something like Cloud Run, you don't have to think about all of the ops and DevOps. You're simply developing. Make sense? We good? So this is an evolution. You might be on bare metal. Probably not. You might be, but we move from bare metal to virtualized. And if you are on bare metal, we actually have solutions for that as well. We have some colos and things where we can offer you bare metal solutions that have low latency, direct access to Google Cloud Platform. But virtualized, and then if you look at that image, it's basically showing that VMs can run multiple containers. And then when we get to serverless, we're really not concerned with infrastructure at all. We're simply running that container.
Joyce, let me interject here again real quick.
Sure.
So Cloud Run is based on containers, right? So give me a container, Cloud Run will run it and scale it up and down more or less as you need. We Google Cloud also offer an actual functions as a service as well. That's more along, if you're familiar with AWS's product, that's more along the Lambda lines. That's functions. Cloud Run is distinct from that in that you get a lot of the benefits about just focus on your code and we'll run it for you. But it comes with containers, which means you can run pretty much anything you want inside that container. You're not restricted to just a few languages that are supported or just certain frameworks that are supported. You get an amazing amount of flexibility and most of the advantages that you would get with functions too. So just trying to make the difference clear between.
Yeah, that's really important. I appreciate you pointing that out. Yeah, I'd mentioned functions and Appigen, but I never really differentiated it. So I appreciate you catching that, right? So functions are a little bit more limited, as is App Engine and the number of languages and things that you can do, whereas Cloud Run is wide open. Go, Ruby, Python, Java, I can't think of them all, but wide range of languages that are supported, and your application that's already containerized can just run on it. Good point. Thanks, Andy. Okay, we're going to move on to scaling data, which this is not at all in-depth, full overview, but I just want to get you the idea of the architecture patterns that there might be and the type of services that we have and how you could control costs. So if we start here with Cloud SQL, that's something everyone can relate to probably, a relational database. So our version of a transactional database available as MySQL, Postgres, and even SQL Server runs a managed service, in that we will manage the hardware and infrastructure for you, and the software and the upgrading of the nodes and things. But you are still choosing a number of instances that you would run of that database. You are choosing how to handle availability of that database. You are choosing a number of vCPUs and memory, and you are paying for operation of Cloud SQL for as long as it is up and running, right? You're paying for those licenses, and you're paying for it to run, right? So that's kind of a traditional, almost a lift and shift sort of model, running very similar to the way you are on-prem. It's probably gonna be on all the time, and you're gonna pay for it all the time. To contrast that with something like a managed service from a serverless managed service from Google Cloud, a good example is BigQuery. So in BigQuery, it's a large-scale data warehouse, and there are two components to its pricing model. One is the storage that you, the number of terabytes or petabytes of storage that you are storing. Actually, it could be gigabytes. We do start small and grow. So that's charged at a rate similar to our bulk storage, which is known as Google Cloud Storage, GCS, right? So that's just object storage, but it's the same price. Whether you're in the data warehouse or you're just storing bulk storage, it's important to know that we're still charging that very low set cost of just a couple of pennies a gigabyte. So while you'll pay for that storage on an ongoing basis, you only pay for what we call compute capacity when you run a query. So you only pay for the size of that query, and it's billed based on the number of gigabytes scanned, right? So the contrast between sort of a traditional lift and shift sort of SQL type database moving to the cloud in BigQuery is that you're always on in a cloud SQL world, whereas BigQuery you're only paying for when you actually run the queries and the size of those queries, and for the ongoing storage that is persistent underneath. Other managed services that we offer in the area of data are often for specific use cases, if you will, whether it's that you need a very low latency database. That would be Cloud Bigtable, which is also a managed serverless service. Cloud Data Store provides you that document database you might be looking for. Cloud Spanner is a global, always-on, high-performant transactional database, and then Cloud Memory Store. So these are things that are managed services, and they are usually just sort of purpose fit for a certain type of data service that you need. How to reduce costs across any of these? Generally, it's around data retention, right? How much every single one of these, no matter whether it was managed or serverless, all have a component of charging for the amount of storage that is stored. In the case of Google Cloud Storage, you can move to longer retention type storage over time. Same with BigQuery, and it happens automatically. If you haven't touched data or a data set for 90 days, it'll automatically move to a cheaper tier of storage, which is half the price, so a penny instead of 2 pennies. Something important to remember when you're considering costs of these data services versus what you have on-prem is that there is built-in replication to many of them, right? So whereas on-prem you might have a terabyte database, and you know that you're doing a replication of that to another data center, so you need 2 terabytes of storage total. In Google Cloud world, if you're in BigQuery, it's being replicated without you having to really calculate that. So 1 terabyte of database has the same value as 2 terabytes on-prem. And then as far as controlling costs on a day-to-day basis with your users, it's important to set quotas. You can limit the number of queries by project, by person, by organization. There are all kinds of cost controls available. And then finally, in the world of our data warehouse, when you get large enough, you can also have flat rate pricing, meaning you're paying for the storage underneath, and you're also just paying a flat rate for an unlimited amount of queries that you want to run. That flat rate comes with scale, meaning you can start small as far as the amount of compute capacity, and your queries will run. They may take longer, but they will run and they will finish. So as you move up the chain, you pay a higher and higher flat rate, you'll find that your performance can get better. depending on the type of application, you may not need a very large amount of CPU to complete them in the time that you need, so you can get away with the entry level flat rate. Any questions on that? On data? I don't see any here in the chat. Okay.
No,
So that something, Andy?
nope. Sorry, saying continue. You're good.
Okay. So that sort of wraps the architectural pattern portion of the conversation, and we're moving on to the administrative portion, which is the managing billing and budgeting within Google Cloud. The key questions you probably want to ask that you're wondering where you can find the answers to within our dashboards are, how much does my app cost? You know, it's nice to know how much BigQuery cost you or that GKE cluster cost you, but how much does my overall app cost? Also might want to know, what are my cost trends? And what are my cost drivers? Am I paying more for storage or compute, or what's the big hitter that my application is using? And then also, how can I optimize my costs? We've talked a little bit about that fourth one already, so I won't be touching that much in this section. The path to more predictable cloud costs is about having visibility, these built-in reports and some custom dashboards I'll show you, and the way to determine trends in your forecast. And having accountability, you have to start to find a way to align what you're consuming with real business principles, meaning how does what I'm using aligned with maybe my East Coast operations or my West Coast operations, or this particular business unit for this particular application? How can I show back those costs so that I have some control and financial governance to get people incented to control their spend and avoid overspending? And then again, these intelligent recommendations for optimizing costs, which are built in every single one of our products. So to explain this a little bit of how do we translate costs for use of individual services in GCP to real world, real life projects that you're running, starts with a lot of resource management concepts that I want to go over. So these are just some kind of high level things that I need to make sure we're all on the same page about. The center of the universe in using Google Cloud is about what's called a project. So a project is a canvas, if you will, a space in which you can start to consume resources. So for any particular application, you might open up a project, and in that project, you start populating compute engines and you start populating databases, and that is where the source of consumption happens, is at the project level. These projects can be organized, and they can be organized in a couple of ways. In a hierarchical system of folders. So maybe you wanted to organize it by geography, east, west, central. Maybe you want to organize it by business unit, meaning HR, finance, sales, whatever it is. Or maybe you want to organize it by application. However you want to do it, you can set this hierarchical set of folders that the projects sit within. And then at a more granular level, inside of projects, when you're using, say, a Cloud SQL database, you can label it with your own custom label. Joe's using this, or whatever project is using it. So you can get these really granular labels that fit your exact business model. All of these projects and the folders that are holding them, the labels that are within them, are controlled by a domain or organization, right? So your org is onboarded GCP, and at that organizational level, you have a lot of control. You need to put a few people in control at the beginning at the org level to determine who's allowed to create projects, who's allowed to consume, who has access to different types of things to consume. Do we allow anyone to start up a SQL database? That sort of thing, and that's controlled at the organizational level by an organizational admin. Projects are billed and tied to a billing account. You really can't have a project without having a billing account. It could be tempting to have multiple billing accounts, but that's not really the way we'd encourage you to organize. I encourage you to organize by folders and things like that instead. Generally, even in our largest customers, they have a single billing account. And that way, by doing so, you can see your total bill across all things that you are deploying to Google Cloud Platform. And that billing account is tied to a payment profile. If you're just getting started with GCP, there's a $300 free credit, so you can get started and play around and learn all about it. You can also do online payment method, meaning use of a credit card or a EFT debit. And finally, the third way to do payment is via offline, which you'll make an agreement for use of Google Cloud, and then we will do some back like offline purchase order type billing for you on a monthly basis. Billing can actually be set up, I understand correctly, is not just on a monthly basis, but also when you hit certain thresholds, if you want to, you can bill out as well.
Yep, that's true.
So I just discussed a number of concepts verbally, and sometimes a picture is worth 1,000 words. It might help you see this a little more clearly. So if you look at this, I talked about projects. You see them there across the bottom, project 1, 2, and 3. That's where you would actually put resources that you wanted to use, compute engines and GKE and things like that. And you could label each of them very granularly if you wanted to. You organize them into folders, as you can see there in the picture, that are held by an organization and that tie to a billing account and a certain type of profile for payment. Getting down to cost management tools, there are a few ways. One, we have billing reports, which provide you the ability to view in a dashboard pre-built for you, not just costs, but also forecasts, right at a glance. There's a number of different filters. I'll show an example of one. You also have the ability to do a billing export. When you're getting into labels and things like that, and you're wanting to sort of slice and dice those bills in a very granular way, having a billing export can allow you to create custom dashboards that fit your org, and I highly recommend doing this. Our billing reports are great when you're getting started, but billing export is something you're going to want over the long term. And then you can set budgets, alerts, and quotas, and I'll give you an example of the ways that you can set those in the following screens here. So this is an example of Cloud Billing Report. I know it's a little bit small, but taking a look at it, it helps you gain visibility into your current costs and trends. If you look at the top left, you'll see it's showing you from February 1st to 25th what your current total spend is across all of your organization. There, it's about $1,600. It's actually giving you a trend versus the previous 25 days that you are increasing your spend. And then on the right-hand side there at the top, it shows you a forecast total for through the end of February, which can be interesting so that you can see what your trends are. Right now, the graph in the middle is SKU based. SKU, we just mean a product or resource like a compute engine or a Kubernetes cluster. So it's dividing the cost and showing you exactly how much you're spending on compute engine. That's the blue one, and you can see it's the bulk of your cost, how much you're spending on storage and et cetera. So if you look at the right-hand side, this is how it was set up. At the top, you see that it's for the current month and it's for all projects. But if you drop down that menu, you could choose from a single project or 3 of the 20 projects or however you want to do it. It's showing a time range of the current month. And again, it's grouped by SKU, but you could actually just as easily group this by project if you wanted to, rather than SKU. Right, so it's pretty good. It provides you that daily, monthly, whatever view, and it gives you forecasts and trends, and allows you to look at it at different angles. So it's a good way to get started. We also have the ability to set budgets and alerts, and you can do them a number of different ways, like projects or SKU or things like that as well. This is just an example of a user who has a number of different reports. Some of them are for their amazing application, they have a budget, or for a particular service like BigQuery plus AutoML, they have a budget. They have a budget for just compute engine. They have a budget for their demo project. You can see you can set them up lots of different ways. This is an example of the screenshots that they would have used. One, you name your budget. You select the projects that are relevant. In this case, they selected 3 of them. You select the products you want to be budgeting for, and you can see they're all listed there. So you could check them individually, have a single one, have multiple, however you want to do it. And then you set the amount and the action you want to take. So for example, in this case, when they hit 90% of budget, of $900 budget, they wanted it to trigger an alert, right? This can actually be hooked up to pub subs, or it can provide you email. So the default is it's going to send you an email alert notification but you can also have that same notification sent to our messaging queue called PubSub. And if you wanted to, you could actually take an action, right? So I wouldn't necessarily recommend it. You need to work with your application teams to make sure it makes sense, but you could perhaps, when you hit a certain budget, shut it down, which is just not something that your users really enjoy, but it is something that can be done. And you can do something even more mild than that, perhaps like reduce the number of instances or whatever it is when you hit your budget. So lots of options. Because it's programmatic, really your ability to customize this is endless. And finally, billing export. Billing export, the most important thing I want to tell you about that is that it's the export and the data that you can get starts from the day that you turn it on. So you want to turn it on day one, right? Because you can never get that data back. You may not need it now, right? I mean, right now, trying to manage your budget with the billing reports is probably going to be entirely sufficient. But as you grow and scale and you have thousands of resources working in hundreds of projects, having the billing export is going to be absolutely necessary. And if you start with it now, you'll learn from it in a smaller scale. It'll be easier to understand. What it does, that exports the data. You can export to CSV or JSON or things like that, but I highly recommend exporting to BigQuery. Very small amount of data. It's going to cost you a couple bucks a month to do this. And then you can use any kind of BI tool that you want to visualize that data. Data Studio is from Google. It happens to be free. We have templates that are already out there, which I don't have the links to, but we can get them for you if you just if you want them, to set up these dashboards that are already kind of pre-built that probably meet the bulk of your needs. And to take a little bit closer look at one of those, the original questions in this presentation were about how much does my app cost? If you look at the right-hand side of the screen, you can see month-to-date spend by project there. So you can see how much you're spending for Solera or Universal or whatever project that you're running. You want to know what are your cost drivers. In the bottom in that pie chart, you can see really at a glance that the bulk of your spend is on compute engine. Maybe it's time to go look at that dashboard and see if there's any recommendations about how to reduce the size of the VMs you're using, or maybe turn some of them off or things like that. Whereas storage costs are just 8%, very small amount of your spend. So that's not a concern. You can continue to retain the data the way you've been retaining it. That's not the concern. So you can start to understand your cost drivers in a very big picture sort of way. You can see the daily and monthly views there as well. And if you want to consider what's the trends in your cost, you can look at that month, quarter, and year-to-date spend and start to see some of those answers come to life. There are lots more dashboards available out there for free for use that can get you even more granular detail with labels and things like that. So as far as best practices, enable data export from day one for billing. You can use billing reports to answer your questions today, because your invoice, when you get it, is just going to be at the org level, a total cost, and every individual product SKU listed and how much it costs, but that doesn't really tell you what your app costs or how much Joe's team is spending. The only way you're going to get that is through these billing reports and exports. And build a culture right from the start so that your developers, your organization, understand how the architectural patterns that they're building, like I talked about at the beginning of the presentation, affect the cost, total cost to your organization, right? So when you start showing these things back and showing them how much using Compute Engine is costing or how much BigQuery is costing, right from day one, that helps them understand and maybe fine tune what they're developing to make sure that it is cost effective. Just to wrap this up, I have a number of resources here available. One, this white paper. I know it's going to be hard for you to get that URL. So if you just search on a guide to financial governance in cloud, it'll come right up top of the page. Google search is amazing, right? Just a plug. And then YouTube, also amazing. If you plug in Getting Started with GCP Cost Management, you will get this presentation that I'm referring to, but you'll also get about a dozen more, and they are rich. I just love, we have Google Next every year. And there's just a wealth of presentations, and all of them are published to YouTube. So you can get all the benefits of having gone to Next right from the comfort of your couch and YouTube. So there's some great talks in there. And then the documentation, I happen to think our docs are pretty fantastic. They walk you step by step. They give you a concept section as well as a how-to. So if you're running how do I do that billing export, it's right there step by step. And then if you want to see some examples of some queries you can do. So while I talked about the dashboard, I kind of skipped over the fact that now all your billing data would be sitting in BigQuery. You can just use SQL queries to ask questions as well. And so do a search on this and you'll find that there's some, oh gosh, dozens and dozens of canned queries that you can use to evaluate your data and visualize it. And that's all I had for today. So I'm open to questions or additional conversation, whatever we'd like to do.
Cool. Joyce, this is Andy again. One further comment I would make is that, and you saw this throughout the presentation, there's a mentality throughout the products that are in Google Cloud that we want you to use these tools because you're getting value from them, not because you're going to spend more and more and more money over time with cloud. So a lot of these cost management features, a lot of these serverless things are specifically aimed at you, the consumer, getting value out of this platform, not necessarily sucking as many dollars as we can out of your wallet. Right? It is frankly, and without naming names, a different mentality than what I've experienced in other public cloud providers, and it's one of the reasons I think this makes so much sense for very small startup teams and for very large enterprise teams. So you'll see this throughout the products that we have here. That said, there was a question that was brought up to me during the presentation, and that was if Joyce, if you might have an answer, I have some ideas about this too. But do you find cloud to be very suitable for serving high volumes of multimedia content, like digital assets of some kind?
Yeah, I find it suitable for, it depends on what you're serving them. I mean, you know a little bit more about the use case, but certainly our ability to use Google Cloud Storage to serve large volumes. I mean, I would assume they're not all being used at the same time. And so the cost effectiveness is that we will automatically move them into longer term storage. So when they aren't used as often, it'll cost you a penny per gigabyte versus 2 cents per gigabyte. So there's some cost advantages to storing in the cloud. Whereas if you store them on-prem, that cost is static. It's built in, and anything that you do on-prem, especially, I used to be quite the expert in data storage. It's sort of a stair-step effect in that you have to buy large bulk storage and then fill it, and then buy and then fill it. Whereas cloud, you can just sort of pay as you go over time, and so it makes a ton of sense in that regard as well.
Yes, we have a lot of companies, both large and small, who are serving lots and lots and lots of digital assets of all shapes and sizes. Doing that, and it's exactly as Joyce has described. All right, any other questions? Feel free to unmute, type other questions in the chat, anything like that.
Yeah, great. We have nearly 7 minutes left, and there's only a couple people on the line, so please take this opportunity to utilize their expertise and ask any questions or scenarios that you have.
And Andy, there's a question in the chat from Amy you guys might want to take.
Oh, I didn't even see that. I still don't see that.
So where's a good place to get experience coding for the cloud?
I'm gonna give that one to Andy.
Where's a good place to get experience coding for the cloud? So it depends a little bit about what you mean by coding for the cloud. But Joyce mentioned just a minute ago that generally speaking, our docs are very good. And whether we're talking about some particular product we have or developing for that product that we have, there are really good starting points there. Google specifically, so if we're talking about Google Cloud specifically, there are a number of GitHub accounts that you can find. I don't remember exactly the name of the main one, but I think it's just Google Cloud Platform on GitHub, where you'll find coding examples for all sorts of things. You'll find SDKs for all sorts of things, cloud related, Google related, that are there. And then in my own experience, the other thing that I've found is that there's we have a whole team at Google known as developer relations, or DevRel, and they put out a stream of content on YouTube faster than I can keep up with it. So there's a lot of stuff that will get you started there and then point you at further deeper content as you go. So I would look at any of those.
One other thing too is right now we're offering our quick labs at no cost. So if you go out to get some of the training from Google, you'll see which of the courses are available. So that may help you get started too. Obviously it's GCP and coding on our products, but it would be free training for you to learn the solutions and how to use them.
Did that answer the question sufficiently? It was Amy that asked, right?
So yeah, so that answered the question. Links would be good. So what I can do is provide some links to Catherine maybe after this. And Catherine, can you send out to the attendees?
Yeah, certainly. I'll be sending a little email later that will include a survey. So we would appreciate your feedback, but we'll include any information that the Google team would like to share.
Okay.
Sure. We can include things about getting started with Cloud Run, getting started with GKE, talking about containerization in general, how to use the object storage like we're talking about for serving media, assets, all those kinds of things are easily findable.
And one thing to point out too, Cintrifuse is a partner with the Google for Startups program. So what that means for you guys who are members of Cintrifuse, you can get access to Google products for free for up to a certain level for a certain amount of time. There is eligibility criteria, so you need to make sure that you fit into that. But that's something that you can work with a Cintrifuse team to see if you qualify and to get access.
Awesome. Any other questions? Participants also have the availability to unmute themselves if they would just like to, chime in or say anything.
Sounds like we're good.
Okay. All right. Thank you guys for joining us. And thanks again to the Google team for providing this awesome content early this morning. And yeah, feel free to reach out if you have any questions. We really appreciate your participation.
Thanks so much.
Thanks,
Thank
everyone.
you. Have a great day.
Take care.